Are we alone in the universe? This timeless question has inspired countless stories, movies, and dreams. But what if one day science, not science fiction, offered a clue that we might not be alone? In 2017, astronomers in Hawaii discovered a mysterious object from beyond our solar system. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. A renowned professor believes this interstellar visitor might not be just another space rock. It might even be evidence of extraterrestrial technology. Today, we'll explore the dramatic mystery of Oumuamua and why this cautious, respected scientist dared to ask, what if it's not just a rock? What if it's a sign that we are not alone? The stereotype of an alien believer might conjure up images of a person in a tinfoil hat. But Avi Loeb defies that stereotype. He is an astrophysicist with a glowing resume, PhD in physics by age 24, former chair of Harvard's astronomy department, author of hundreds of scientific papers. Loeb isn't a fringe outsider, he's a mainstream scientist. And yet, he is one of the most prominent voices suggesting that at least one interstellar object could be evidence of alien life. How did this respected researcher come to such an extraordinary hypothesis? Let's set the stage by looking at Oumuamua itself. On October 19, 2017, the Pan-STARRS-1 telescope in Hawaii spotted something unprecedented, a tiny point of light moving rapidly across the sky. It was soon identified as the first confirmed interstellar object ever observed in our solar system. In astronomy, an interstellar object means it originated outside our solar system, traveling through the space between the stars before happening upon us. For decades, scientists predicted such visitors existed, but Oumuamua, officially designated 1I 2017 U1, was the first time we actually saw one. It was a historic moment, humanity's first known visitor from another star. Astronomers were thrilled and puzzled. Oumuamua was faint and fast. It was already heading out of the solar system when detected, so we had only a brief window to observe it. It had come from above the plane of planets, swung past the sun, and was now racing away beyond Earth's orbit. Calculations showed it wasn't bound to the sun's gravity. Its path was a one-way ticket past us, confirming its interstellar origin. The name Oumuamua was chosen to reflect this one-of-a-kind event. It means scout or messenger from afar in Hawaiian, a fitting moniker for the first emissary from another star. What really grabbed attention was that Oumuamua did not behave like any comet or asteroid we had seen before. Observations suggested it was oddly shaped, possibly 10 times longer than it was wide, making it extremely elongated. Some likened its shape to a cigar. Later analysis hinted it might be flatter, like a pancake or disc. Either way, it was nothing like the roughly spherical or potato-shaped asteroids we know. Stranger still, it showed no visible comet tail, no cloud of gas or dust around it. Typical comets, when warmed by the sun, shed gas and dust that form a glowing coma or tail. Oumuamua, despite passing relatively close to the sun, stayed eerily point-like in telescopes, with no fuzzy halo, no tail. Then came perhaps the biggest puzzle. As Oumuamua was leaving our solar system, it sped up slightly, as if given an extra push away from the sun. Normally, an object moving under gravity alone slows down after rounding the sun. But Oumuamua's velocity showed a small but notable boost. In comets, such acceleration can happen due to outgassing, jets of vapor acting like tiny thrusters. However, as mentioned, no outgassing was observed. No comet-like activity was visible, yet something made it accelerate. To astronomers, it was as if Oumuamua had a hidden power source or someone stepped on the gas for a moment. A truly enigmatic behavior. Let's recap the weirdness of Oumuamua in simpler terms. Shape: extremely elongated or flat, unlike typical asteroids. No coma tail, no obvious gases or dust, unlike known comets. Unexpected acceleration: a small extra push away from the sun with no visible cause. Each of these traits was puzzling. Combined, they made Oumuamua unique in the annals of astronomy. Scientists around the world proposed various explanations. Perhaps it was a dense rock that held onto its gases, or a shard of pure ice that evaporated invisibly. One idea was that it might be a hydrogen iceberg, frozen H2, that could sublimate without leaving a detectable trace. Another paper suggested it was a fragment of a Pluto-like exoplanet made of nitrogen ice, eroded by eons in space. These natural explanations tried to account for the odd acceleration and lack of tail, yet none of them proved conclusive. Each had uncertainties. The truth is, we never got to collect more data. After a few weeks of observation, Oumuamua was too distant and faint to see anymore. Its true nature slipped beyond our reach, leaving scientists with educated guesses but no definitive answers. As one astronomer put it, the true nature of this enigmatic interstellar nomad may remain a mystery. All of this set the stage for Avi Loeb to propose an audacious hypothesis. Where most saw a cosmic oddball to be explained with known physics, Loeb asked, what if Oumuamua was not a natural rock at all? What if it was artificial, made by an intelligent civilization? Avi Loeb was fascinated by Oumuamua from the start. As a scientist, he was drawn to its unexplained features. At a time when many experts were scrambling for natural explanations, Loeb made headlines by openly considering an alternative. He suggested Oumuamua might be an alien spacecraft or a piece of alien technology. This claim sounded sensational. Coming from a less credentialed person, it might have been dismissed outright. But remember, Professor Loeb is a highly respected figure, a former Harvard astronomy chair and advisor to presidents. He wasn't claiming this on a whim. He had scientific reasoning to back it up, however speculative. Loeb and a colleague published a scientific paper positing that Oumuamua's properties could be consistent with an artificial origin. For instance, the unexpected acceleration might be explained if sunlight was pushing on a large, thin object, much like wind pushing a sail. Loeb suggested Oumuamua could be a kind of light sail, perhaps a defunct piece of spacecraft propelled by starlight. Its extreme shape and tumbling motion might fit if it was a flattened disk catching the light. The lack of a comet tail was naturally explained if it was not a comet at all, but metal or some composite material. To be clear, Loeb never insisted for sure it was alien technology. Rather, he argued, we should consider the possibility because the object was so strange. In his words, as a scientist, I want to figure it out, whether that answer is prosaic or extraordinary. This hypothesis certainly grabbed public attention. Imagine a piece of alien technology right there, zipping through our solar system. It sounds like science fiction, yet here was a sober scientist suggesting it as a real possibility. Loeb pointed out that if we never consider unusual explanations, we might miss truly groundbreaking discoveries. Sure, 99 times out of 100 a weird observation has a mundane explanation. But what if this is the 1 in 100 that doesn't? He often emphasizes that science should be willing to ask big questions. There is no bigger question in science than, are we alone? Loeb said. And for him, Oumuamua brought that question to the forefront. Let's step into the imagination for a moment. What if Oumuamua were an alien craft? Perhaps not a spaceship with creatures aboard, but maybe a probe or discarded technology from a distant civilization. Picture a thin, raft-like object, tumbling end over end as it enters our solar system. It's silent and cold, but as it nears our sun, light presses on it, causing it to speed up ever so slightly. Maybe it's a solar sail from a long-ruined spacecraft, or a beacon designed to activate when passing close to a star. It doesn't emit signals, none were detected, but its mere existence could be the message, you are not alone. This imaginative scenario might sound far-fetched, but it captivates the mind. It's the kind of outside-the-box thinking that Loeb was willing to entertain, all while grounding it in known physics, like radiation pressure on a light sail. By blending rigorous science with a touch of imagination, Loeb kept a sense of wonder alive in the discussion. Loeb's idea was met with a mix of intrigue and skepticism in the scientific community. Many scientists argued that natural explanations should be exhausted before considering aliens, and indeed, several research teams published papers arguing that known phenomena could explain Oumuamua. One team's calculations suggested it was a tiny, weird comet after all. Maybe it vented gas in a way we couldn't see, giving it that acceleration. Others proposed exotic ices, as we mentioned, hydrogen or nitrogen, that could evaporate without a visible tail. The prevailing sentiment, Oumuamua showed no direct evidence of artificial origin. There were no radio signals detected, and the smooth acceleration didn't look like a controlled engine burn. In fact, a 2019 analysis noted that if it were a spacecraft with thrusters, we might expect sudden changes in speed or direction, not the steady push observed. And its tumbling motion, it appeared to tumble chaotically, isn't what you'd expect from an active ship under guidance. Some colleagues were blunt in dismissing the alien idea. To them, invoking aliens felt unnecessary and sensational. Why jump to an extraordinary conclusion when a dark comet, a comet without visible outgassing, might do? Loeb responded that calling Oumuamua a comet without a tail is like saying an elephant is a zebra without stripes. In other words, using an oxymoron rather than admitting we have something new. The debate highlighted a deeper divide about how science should handle the unknown. Loeb felt that assuming the answer, e.g. it must be a comet, could blind us to true surprises. His critics felt that extraordinary claims, like aliens, require extraordinary evidence, and that evidence just wasn't there. Through it all, Loeb remained undeterred by detractors. "I don't really care what people think," he said regarding the pushback. "Science is not about us lecturing the public what's right or wrong. It's about the process by which we all learn together." In Loeb's view, exploring a controversial idea is not a sin, it's part of the scientific process. You propose a hypothesis, collect data, and see if it holds up. If it turns out wrong, so be it. That's progress. As he often remarks, "I don't care if I'm wrong. This isn't about me." His thick skin in the face of criticism and willingness to challenge conventions garnered both applause from those who admire scientific curiosity and criticism from those who felt he was giving weight to an unlikely idea. This controversy itself became a story, covered in major news outlets and sparking public interest in Oumuamua's mystery. So what's the verdict? Natural or artificial? Truthfully, we don't know for certain, and we may never know. Oumuamua is long gone, now far beyond Pluto's orbit, too distant to observe. No telescope can currently reach it in time. Without more data, scientists can only argue based on the limited observations and physics models. The consensus leans toward natural origin, a weird comet or chunk of ice. But Loeb's perspective keeps the door open that we encountered something truly extraordinary. The key takeaway is that Oumuamua remains an unsolved mystery. And in science, an unsolved mystery is exciting. It means there's more to learn. For Avi Loeb, Oumuamua wasn't the end of the story, it was the beginning. In the aftermath of the debate, he galvanized efforts to systematically search for evidence of extraterrestrial technology. He now leads a venture called the Galileo Project, which is installing observatories and encouraging sky searches to spot the next Oumuamua or even UFO-like phenomena. The idea is to bring rigorous scientific instruments to the hunt for the unknown. Loeb believes if we keep our eyes open, we might catch another interstellar visitor, and this time we can collect more data, maybe even images or samples, to finally get answers. Discovering alien technology could be the biggest leap for mankind, Loeb says. It would transform our understanding of our place in the universe. Loeb also stays on the lookout for unusual discoveries. Recently, he investigated materials from a meteor that struck Earth in 2014, which he suspects came from outside the solar system, essentially another interstellar object that actually collided with Earth's ocean. He even led an expedition to retrieve fragments from the ocean floor. This shows his commitment. He's literally digging for evidence that might show technological composition or anomalies. While controversial, these efforts keep the scientific community engaged and the public fascinated. Even if all these investigations turn up only natural phenomena, we learn more about our cosmic environment. And if just one yields something truly artificial, well, that would be a world-changing discovery. Notably, after Oumuamua designated 1I, the second interstellar object, 2I Borisov, was discovered in 2019, and it looked just like an ordinary comet, with a nice tail and everything. That suggests most interstellar visitors might be comet-like after all. And just recently, a new one dubbed 3I Atlas was found, which has scientists excited and debating again. Loeb even speculated it could be another technological object due to its unusual brightness, though others strongly suspect it's just an odd comet. The field of interstellar object research is just beginning. We expect many more objects in coming years, especially with new powerful observatories coming online. Each new visitor will be an opportunity to learn and to test ideas like Loeb's. Let's step back and think about what this all means. Suppose one day we confirm that an interstellar object was indeed artificial, essentially a message in a bottle from another civilization. How would that change the way we see ourselves? It would be a profound moment in history. Loeb often muses that encountering alien technology would teach us humility and possibility. They may be far more advanced than we are, with bigger brains or artificial intelligence far beyond ours, Loeb said about potential extraterrestrials. They may know more about science. Let's just observe and listen. His approach is one of open-minded curiosity, coupled with scientific rigor. Whether or not Oumuamua was alien, Loeb believes keeping our minds open to that possibility is healthy for science. It pushes us to gather better evidence, to not take our first assumptions as final, and to remain curious. On the other hand, even if Oumuamua was a purely natural visitor, it's still amazing. It means pieces of distant solar systems can pay us a visit, bearing information about their composition and origin. In a way, it's like getting a free sample from another star system. As one scientist noted, Oumuamua gave us insight into what other planetary systems might produce, perhaps shards of planets or strange comets roaming the galaxy. The universe has billions of stars, and likely trillions of wandering objects. Just the fact we found one in 2017 and another in 2019 tells us the galaxy is filled with cosmic travelers. Some might even be floating debris of civilizations. Who knows? The mere possibility inspires us to keep looking up. The tale of Avi Loeb and Oumuamua is a compelling blend of science, curiosity, and cosmic wonder. It reminds us that sometimes the biggest discoveries start with someone brave enough to ask an unconventional question. What if we are not alone? It's a question that ignites the imagination. Oumuamua's fleeting visit left us with more questions than answers, but it also left us with a sense of awe. In a vast cosmos full of stars and mysteries, our tiny world got a sudden visitor. Perhaps just a rock, perhaps a relic of another civilization's efforts. We may never know for sure, but the pursuit of that knowledge is moving us forward. In the end, whether Loeb is right or wrong about Oumuamua doesn't diminish the value of asking the question. Humanity's progress has always depended on explorers and scientists who push the boundaries of the known, who prepare to be wrong in the hope of discovering something truly new. As we gaze up at the stars, let's keep alive that childlike wonder, the willingness to imagine beyond the immediate explanations. After all, the next interstellar object might already be on its way. Will we recognize it for what it is? Will it answer the question of cosmic loneliness or deepen the mystery? One thing's for sure, we'll be watching. Stay curious, keep exploring, and remember, somewhere out there in the dark, there may be other eyes looking back. Until next time, keep pondering the cosmos.